Okay, guys, welcome to lesson 32. We are finishing up this module, and so for the end of the module, we draw on some skills that we've already learned about, writing numerical expressions, but we're just going to be changing it out now with fractions. So if you look at our objective, it says to interpret and evaluate. So we've talked before, evaluate means solve numerical expressions, including the language of scaling and fraction division. So let's go throw some vocabulary at us. It's things that we already know that we've been doing here in class, but that we're going to put some vocabulary with it now. So take a minute, make sure you've got the objective written down so that you understand our purpose today. And please remember that you really need to watch this lesson the whole way through, taking notes the whole time. Quitting early because it seems to be easy, well, that's kind of how this is designed. It's designed to start easy as kind of a review, and then it builds and builds and builds until the end is pretty complicated. So it's important that you stick with it for the entire lesson. All right, so we're going to go ahead and we're going to get started on problem 1. And it tells me that I need to write word form expressions numerically. So that means they're going to give me the words and I need to change it into a number. All right, so this is where our math vocabulary really comes into play. These intimidate a lot of you. And so really what we have to do is we have to attack it left to right. So what we're talking about is the order of operations. And many of you know it as PEMDAS. And so what that means is that there's a certain way that you have to solve a math problem that has more than just one number sentence. So for example, you might see a number sentence that has some parentheses, exponents, multiplication, division, addition, and subtraction, and you have to know how to attack it, because if you don't do it in the correct order, then you will not get the correct answer. So I'm looking for keywords here. And so the way that I like to attack these is I like to look at the vocabulary. Well, I know that twice means 2 times. Like if I say, oh, I went to the grocery store twice yesterday, that means that I went 2 times. Some means that I'm going to add something. All right? So I know here I've got 2 numbers. I've got 3/5 and I've got 1 1/2. So I've got to look at what it tells me right in front of that. It tells me that I have to find the sum of this number, these 2 numbers. So I'm going to write 3/5 plus 1 1/2. So I'm done. I've used all of that. Okay? The next part of my word form tells me that I need to do 2 times that sum. Okay, so this is where we have to remember our PEMDAS. I have to do whatever is in parentheses first. So because it tells me that I have to find the sum of these 2 numbers, I want to make sure that they stay together. I don't want them to get separated by any other operation. I need those 2 guys to stay together. So I'm going to put my parentheses there so that whoever goes to solve this equation knows that I need to find the sum here. So now I'm left with 2 times. So I can put my 2 times here. Or sometimes you'll see it where there's no times symbol. It's the same thing, but they've just taken out the times symbol. Or I could even say 3/5 plus 1 1/2 times 2. Now in that case, I wouldn't necessarily need to put my, or no, I would have to put my parentheses, because if I don't put my parentheses, then somebody, because you have to do multiplication first, they would multiply 2 times that number, and that's not what I want. I need that number to go with the sum. So since it tells me that, oh, actually, you know what? This set doesn't even tell me that I have to evaluate here. It just says that I have to write the word form expressions. So that's all I need to do. It does not tell me to evaluate. So one of these would be my answer. And they all three mean the same thing. They're all equivalent. So I can do that anyway. All right. Letter B. And I'm going to write this out in word form first. Expression form. Letter B says half the sum of 3/5. And I'm going to guess 1 1/2. Yep, 1 1/2. Okay, so this one's kind of already started for me because we did this up here and it's the exact same sum of and these two fractions. I know that I'm going to add and I'm going to use these two fractions. So I'm going to go ahead and I'm going to do that right now. Sorry, I'm going to write it backwards because I started. And just like the last time, because I need their sum, I'm going to put them in parentheses. Because really, if you look at the order of operations, addition's really, he's like the last thing you do pretty much. So what we want to do is we want to make sure that we keep those two together because I've got to find their sum. And if somebody's adding, that'll be one of the last things they do. And so they won't get that taken care of right away. They might not end up together. And my number sentence says they need to be together because I'm looking for the sum of those two numbers. Now, this is half, okay? So half can be represented as a fraction, all right? Or a fraction is also the same thing as dividing by 2. So really, again, there's different ways that you could do this. So one way that I could do this is I could find the half of, or half, and I take the x out because I don't necessarily need that multiplication sign if I've got these parentheses. Or, are you ready? I got another one. I could do 3/5 plus 1 1/2. And I could put that over 2 because I want to find half of it. And either of these things represent half. Oh, I could also move my half. I can move that down here. So I've even got another way. 3/5 plus 1 1/2 times 1/2. So right here is one number sentence and 1, 2, 3, 4 different ways to write it. And I very well could be missing another way. So it's really, this is one of those things where there's no right or wrong answer. It's a matter of, do you have the numbers together that need an operation in the parentheses that let the mathematician know when to do that? So let's take a look here now at another one, C. And C says the difference. So this one's going to be a little bit different. The difference between I'll come down here to my next line. 3/4 and 1/2 divided by 3. Okay, well, this just got a whole lot more complicated because the last one matched the first one, so I had some of the work done. Now I'm going to have to start a whole new line of thinking. So difference means subtraction. And between means it wants to know how far is 3/4 and 1/2 apart. So if I had a number line and there was 3/4 and there was 1/2 and I had maybe some plots on there, that I had those points plotted, how far is it between them? So the way that I would find the difference is to subtract. So since it tells me the difference between 3/4 and 1/2, I know I'm going to subtract those two. Now, because my number sentence tells me that I need those two to be together, what am I going to do to them? I'm going to put them in parentheses. Good. Divided by 3. So this answer has to be divided by 3. So I can't put 3 divided by because this is my answer and I'm going to either divide that by 3 or put that in parentheses again. Okay, so it lets the mathematician know that I need to find the difference here between these two numbers. That is my first step, so I put them in parentheses. Then I would divide that by 3. All right, so let's go ahead and move on to problem 2. And now it's going to switch up on us again. I'm sorry, I'm looking at this through my phone while I'm writing. Problem 2 says to write numerical expressions in word form. So now they're flipping it on us. So here they gave us word form and we put it into numbers. Now they're going to give us the numbers and we're going to have to put it into word form. Now I don't want you to panic. You can do this. It might be confusing, but guess what? You can do this. And so A, I have 2/5 times 1/2 take away 4/10. So I'm going to use the models that have already been done for me. So I know the way that I'm going to describe this is that I'm going to call it the difference between, not subtract 0.4 from 1/2. That is not what we're doing here. We're looking for mathematical language. So I'm going to use these models. So I'm going to say 2/5 of, oh, we've used that so many times, or 2/5 times. I could do either one. I could use that word or I could use the word of. The difference between 1/2 and 0.4. See, that's not too bad, right? All I did was take what I did up here. I used their language because I don't have to invent my own language. It's already been used by mathematicians for all of these thousands of years. So I don't have to do that part. I just have to make sure that my answer sounds like a mathematician wrote it. All right, so let's see if I can get B on this side here. So B, ooh, this one looks complicated. Plus, I'm already thinking adding. The fancy word or mathematical word for adding is sum divided by 1/3. Okay, so since this is in parentheses, I'm going to want to do this first. So I can say, I know that this is going to be sum. I'm adding them together. So the sum of 3/4 and 1.25 divided by 1/3. That's it. It's just like reading, left to right, and you're writing down what's happening using the idea of PEMDAS, letting them know which numbers need to be put together. And that's what these magical mathematical operation words do for your mathematicians. They understand what to do with those two numbers that are together. All right, so make sure that you use this part here. I'm going to switch paper so you, if you're not caught up, you probably need to pause the video right here and make sure your notes are caught up. And I'm going to move on to C. We're going to continue to get more difficult because our brains are stretching and growing. And so I have C. And this is 2 divided by 1/5. I guess I should have made my parentheses bigger there. Times 0.3. All right. So right here, what would I call the answer of two numbers that I'm dividing? We've been using this so much this week. As a matter of fact, I'm almost tired of saying it that we've been using it so much. So I'm going inside the parentheses because PEMDAS tells me I need to do parentheses first. So I'm going to tell my reader the quotient. See, I knew you guys knew that word. The quotient of 2 and 1/5. And then what happens outside the parentheses? Times 0.3. Could I also rearrange this and say 3 times the quotient of? I could, but that's not really how the number sentence is laid out. All right. So if you think about what the number sentence says, this is the order in which it goes. So when I come back to this first page, I'm so sorry that that's slipping up. When I come back to this first page, and now that I know that, twice the sum of, really my answer should have to be one of these two, because down here it would be the sum of 3/5 plus 1/2 times 2. But the words say twice the sum of. So back here, since the 0.3, the 3/10 comes last, it goes last in my sentence. So it's important to pay attention and make sure that your number sentence matches your word sentence, your word expression here. All right. So now I'm going to tack in another word for you. Okay? So now we are going to come back to my notes. We're going to write in numerical form, and this time we are going to evaluate. Evaluate means solve. No word evaluate, you don't solve it. You just write the number sentence. It says evaluate, you have to solve it. All right. So I'm going to come onto a separate sheet of paper here so that I can actually have a little bit of room to work these. So I'm going to come back to A. Here I have 2/5 times 1/2 minus 4/10, or the difference of 1/2 and 4/10. So now I get a chance to practice all the skills that I've learned in this unit, which is a great review for the upcoming end of module assessment. So first things first, I'm going to rewrite this. 2/5 of 1/2 take away 4/10. All right, so I cannot subtract with unlike denominators. So I'm going to put this 2/5 here. I haven't used it yet. I want to find a common denominator of 2 and 10. So the first thing I'm going to check is, can 2 go into 10? 2, 4, 6, 8, 10. It does. It goes 5 times. That means that I can leave 4/10. I can use 10 as my denominator. So since I multiplied this by 5, I have to multiply this by 5. It's just what we've been doing in math this week, finding an equivalent fraction. So 1 times 5 is 5, which makes sense because 5/10 is the same thing as 1/2. So now I'm going to come down here and I'm actually going to solve what's inside the parentheses. So I have 2/5 times 5/10 take away 4/10 equals 1/10. Now I can just multiply straight across. 2/50ths. They're both even numbers. So I can say 2 goes into 2 one time, 2 goes into 50 25 times. I could also go ahead and kind of cross simplify here. And then I can just say 1 times 1 is 1, 5 times 5 is 25. So it's simplifying when the numbers are smaller here. It's got to be its neighbor or its partner across. And if they are factors of one is a factor of the other, then you can simplify. All right, so let's look at B. B, I had 3/4 plus divided by 1/3. All right, so again, fraction decimal, I'm going to go ahead and rewrite this plus 1, because I have 1 whole, so that's 1, 25.25. I could say 25 hundredths. Okay. Divided by 1/3. Can't forget about that guy. He's still there. So now I want to change the denominator here. So I know, because I keep thinking about money, I'm always thinking about money, it takes 4 quarters to equal $1. So I can change that 4 into 100 by multiplying by 25. Parentheses. Divided by 1/3. All right, ooh, looky here. 25 plus 75, oh, that's 100. So that's going to give me 100 over 100. We know that that is 1 whole plus that 1 that's already there. So now inside my parentheses, I have 2. I'm going to come over here. 2 divided by 1/3. And so then I know 2 times 3 is 6. All right, so now I have evaluated this numerical sentence. All right, we're going to do one more here, C. Okay, now don't be telling me that you can't do this because this is too hard, because you can do this. All right, all of you can do this. You've got to push that block out of your way that it's too hard, and you have to figure out, how am I going to do this? You need to change your mindset into one that says, I can do this. I just need to figure out how. You cannot be afraid of it. It's not going to come up and bite you if you do something wrong, okay? So here, I can work this right here in the parentheses, and I'm going to get 10 times 3/10. All right, and that tells me I'm going to move my 0 or my decimal one time. So my answer here is 3. So this is really a great lesson of synthesizing all of the skills that we have learned in this module. Now it does require you to think and to do multiple steps and to just slow down and take a step back and look. So I'm really hoping that that's what you're going to be doing. Tomorrow I'll have the problem set available for you to view so that you can turn in your homework to me tomorrow. We will have math after the field trip. So you guys have a good night. I hope this video was helpful. If not, go back, watch it again, watch it a couple times, practice it if you want to. And I will look forward to answering your questions tomorrow. Have a good night.